BTEC Applied Science. What we're going to do in this video is have a look at a Unit 1 physics paper. Okay, I'll do a chemistry one, I'll do a biology one. This is having a close look at a Unit 1 physics paper. I'll give you a few tips on how to go about doing it, so you'll know what to expect, etc., etc. June 2017. So it's going back a good few years, so it shouldn't get in the way of any mocks or anything. So, first of all, write neatly in black pen. Yeah, bring a pen, bring a black pen, bring a couple of black pens and write neatly. If they can't read your answers, then they won't give you any marks. Write neatly. Bring a ruler. You will see that you will need a ruler. Okay, so bring a ruler. Bring your own calculator. You know, on a calculator, there's lots and lots of different buttons, and most of them you'll never use. But there are some clever buttons on there, and you'll need to know where they are. You know, finding the square root of something. You know, doing times 10 to the button. Very, very important. And if it's your own calculator, and you are used to it and you know where these buttons are, it'll save you a hell of a lot of time. You'll be a lot less likely to make mistakes. You know, I can tell students who want to do well, who want to succeed, even if they're rubbish at maths, they bring a calculator. I'm sick of saying it to some classes. Bring a calculator. Get used to your own calculator. Look at how many marks there are for the question. If there's 1 mark, you don't write 3 or 4 sentences. If there's 3 marks, then you do. Okay? Look at how many marks. Generally, the marks give you a good idea of how long to spend on each question as well. Look at the marks. You know, there'll be a 6-mark question, and for that one, you need to write loads. Okay? If you haven't got a clue, if you're doing a question, if you haven't got a clue, leave it and then come back to it later and write something down. You know, if you have a vague idea, then guess. You never know, you might get a mark. But my best bet is if you haven't got a clue, leave it for now, come back later, finish it off later. If it's like a numerical one, I mean, do as much as you can, but don't get bogged down. Don't spend 5 minutes banging your head against a wall for 1 mark. It's not worth it. If you do get a calculation, write down the equation. Write down the equation, rearrange the equation. Put in the information that you've been given after you've rearranged it. Yeah. Be careful with units. You know, if it's in centimeters, change it to meters, etc. Work it out on your calculator. Write down the answer to a sensible number of significant figures. We'll go through this process when we do this paper. There's a couple of examples, okay? Now, for the physics, you'll get 30 minutes, yeah? That should be plenty of time, okay? But you don't have time to relax, yeah? Get your skates on, get moving. If you have time at the end, that gives you time to check your answers. Once you've finished, check all of your answers, okay? For the long answer questions, you might think of 1 or 2 extra points to make. When you've checked all your answers, check them again. Keep checking until somebody says stop. Okay? 30 minutes. If you've revised, 30 minutes should be enough. Right, let's dive in. Oh, by the way, the front of the page, read it, you know, before they say you can start now. Read the front of the page, use black ink, fill in the boxes at the top of it. This is on the front. Answer all of the questions. Answer the questions in the spaces provided. And that's because your paper will be scanned and then the marker will be kind of access it on a computer. And if it's outside the boxes, then they might not see what you've written. So make sure you answer in the spaces provided. Okay? It says the total marks for the paper is 90, and that's because they actually give it's the biology and then the chemistry and then the physics, and each one is half an hour, and you do them together. Okay, The marks for each question are shown in brackets. I mentioned that. You get a formula sheet, okay, and you get a periodic table. Read each question carefully, try to answer every question, and if you've got time at the end, check. This is the formula sheet. Now, we say you don't need to learn your equations, but you should be familiar with them. If you've done enough revision, you should know them anyway. But these are the equations that you won't need all of them, but there's certainly a few of them that you will need. Now, let's dive in. So, question 1, give the amplitude of the wave. So this is a wave. Now looking, this is displacement against time, okay? The displacement, it says it's in centimeters. So the amplitude is the maximum displacement. So I reckon the amplitude is 1.5 centimeters. 1.5 centimeters. Yay, we're not going to get 0. Calculate the periodic time of the wave. So the time for one oscillation, so up and down once, and this is time in seconds, so the periodic time will be 2 seconds, won't it? 2 seconds, okay? Strictly speaking, that we should have written in there, but doesn't really matter. The student investigates a different water wave. The wavelength is 0.05 meters. The wave speed is 0.075 meters per second. Calculate the frequency. Show you're working. So the equation you should know is V equals F lambda. That's velocity is frequency times wavelength. V equals F lambda. It's on the formula sheet. This is asking us to work out the frequency, so we need to rearrange it. So F equals, and rearranging that equation, you should be able to do that, V over lambda. Do that before you bung in the numbers. Then you bung in the numbers, so it's dead easy now. So the speed is 0.075, so 0.075. That's meters per second divided by 0.05 meters. So we don't need to change anything to meters because it's already there. Equals, I'll quickly do this on my calculator, 0.075 divided by 0.05 equals, syntax error, 0.075 divided by 0.05 equals 3/2, which is 1.5. Press the SD button. 1.5, and frequency is measured in hertz. Okay? Write down the equation. Rearrange it if you need to. Substitute the numbers in there. Work it out. Okay? We're not worried about the units because we're already given the units in the answer. Do you know, there's 3 marks for that. If you got as far as there, you'd get at least 1 mark. Okay? Next. A radio program can be transmitted as an analog signal or a digital signal. What is meant by the term analog? What is meant by the term digital? You've revised, you've learnt this. It was on one of your flashcards, which you had a look at in the morning. An analog signal, basically the value of the signal can have any value. It's continuous, okay? It won't harm you at all to do a little sketch. Okay, so the value, write down the words. I'm not going to write it out with my mouse. The value can have any value. It varies continuously with time. Whereas with a digital signal, it can only have 2 values. There are only possible 2 values, which is either high or low. And we call these 2 values, usually we call them 1 and 0. Okay, 1 and 0. So a digital signal can only have two values. Do a little sketch, 1 or 0. An analog signal can have lots of different values. It varies continuously, and lots of different frequencies as well. There's only one mark for each of those. We've said enough. Light travels through optical fibers by total internal reflection. You should know what that is. Diagram shows a ray of light. Diagram is incomplete. Complete the path. So with a ruler, now internal reflection, so it's not refraction, it's reflecting. So with a ruler, and you don't need a protractor, it goes bounce, and then when it gets to there, it'll go bounce, and then when it gets to there, it'll go bounce, and then that's enough. Okay. The idea is that the inside of the fiber will act like a mirror, and the ray of light will come bouncing off, yeah, at the same angle. So that will be about 45 degrees. Okay, in fact, all of the angles will be about 45 degrees, something like that. 2 marks. Television programs can be transmitted through optical fibers using digital signals. Explain 2 advantages of digital signals compared to analog to transmit television programs. So explain 2 advantages. Yes. Now, 2 advantages spring to mind for me because I've revised and I know my stuff, and they are, now you write down in words, okay, I'm doing it briefly, that digital signals can carry lots more information, yeah, lots more information. If you think about it, you know, your digital television, you can have like 200 channels, and it's like high definition. Okay, lots more information. It basically but there you information. There you go. You're listening, aren't you? Forgive me. Okay, you could say it has a bigger bandwidth. It can carry more information. So lots of channels, lots of high quality, high definition channels. The other big advantage, now both types of signals pick up noise, but with a digital signal, it's easier to filter out noise. Okay, so easier to filter noise. Easier to get rid of, to filter. Doobie doobie doo. Doobie doobie. Easier to filter noise. I'll explain that a bit more. Like, there's your original digital signal, yes, but then we pick up some noise from somewhere. You know, your big sister's using a hairdryer upstairs, whatever. You pick up some noise, and is that going to mess up your signal? Well, no, because then what you do is you put it through a filter, and you can get rid of that noise and get back to the original again. And it's a lot harder to do that with an analog signal because it doesn't recognize the ones and the zeros. Anyway, there you go. 4 marks. Spend a bit of time on it. Visible light transfers energy as a transverse wave. Sound transfers energy as a longitudinal wave. Visible light moves faster than sound. Give 2 differences between visible light and sound waves. 2 other differences. Well, things that you should know. Light waves can travel in a vacuum. Yeah, they can travel through space. I'm just making a note here. So light waves can travel through space. Okay. Light waves can travel through optical fibers, can't they? Yeah. So you can carry signals. Well, you can carry signals with sound waves if you talk to somebody, but optical fibers, they can be used to carry information, but the light waves can carry lots more information, can't they? There's a digital. I suppose that's another thing, is that light waves can carry a digital signal. Sound waves, I think you might be struggling there. Lots more information. I mean, you know, if you said something like your eyes detect light, but don't detect sound, your ears detect sound, but don't detect light, I mean, that's correct. That should get a mark as well. Now, a painting is displayed in a dark room. An electrician fits a single light source to illuminate the painting. The intensity of the light 1 meter from the source is 100 watts per meter squared. The intensity of the light falling on the painting must not be greater than 30 watts per meter squared. Okay, calculate using the inverse square law the minimum distance the light source must be placed from the painting. Oh, wow, this is a nice question. So the equation that we're going to use, first of all, it's like inverse square law. So the intensity equals a constant over x squared. So the intensity is this, thing here, like 100 watts per meter squared. It's the power, the amount of energy per second per meter squared. That's the intensity. X is the distance, and K is a constant. And I can do these. I know that what we're going to do, one way of doing it is to work out the value of the constant. And then if we work out the value of the constant, we can work out either the intensity or the distance for any particular situation. So we're given enough information to work out the value of the constant. So the first thing we're going to do is work out the value of the constant. So I'm going to rearrange the equation. So K equals Ix squared. Now we are told that when the painting is, or the light source is 1 meter away, that the intensity is 100. So K is 100 times 1 squared, which is very nice because that just means that a value of K is 100. Okay. Now, what the question is asking us to do is work out the distance when the intensity is 30. So what will the distance be when the intensity is 30? So what I'm going to do is I'm going to rearrange my equation again. So x squared equals K over I. So x will be the square root of K over I, which equals the square root of 100, because that's my value of K, divided by 30, equals, on my calculator, so 100 divided by 30 equals square root equals, and I get 1 point. Now my calculator says 1.82574 blah blah blah. I'm just going to write 1.83 meters. Yeah, you can't go wrong with 3 sig figs. 1.83 meters. This is probably the hardest question on the paper. I know that a lot of students aren't very good at maths. Just do your best is all I can say. It is the hardest question on the paper. If you don't do it, you've lost 3 marks. You'll survive. Let's move on. Right, let's look at this. A satellite orbiting the Earth collects information about asteroids that might hit the Earth. A research team needs to collect a large amount of data from the satellite. The chart shows how the regions of the electromagnetic spectrum with different frequencies are absorbed by the Earth's atmosphere. Wow, lots of information, very complicated looking graph. Hopefully you might have seen it before. It's basically how much is absorbed by the Earth's atmosphere. Now looking at this graph here, see, you might recognize there's visible light, there's infrared, there's radio waves there. Basically, over here, gamma and X-rays are absorbed by the Earth's atmosphere. So if you wanted to send information, if there's your satellite in space there's your satellite, and you want to send information to the Earth, okay, you wouldn't use gamma or X-rays because it would all be absorbed by the Earth's atmosphere. Visible light, some of it gets through, okay? You'll see that some of it is absorbed, like the smaller wavelengths are absorbed, the bigger wavelengths get through, but some of it is absorbed. Some visible light is absorbed. Some infrared gets through, okay? Microwaves are all absorbed, they're all absorbed. Now, between here and here, these radio waves get through no problem whatsoever, yeah? So depending on the frequency, depending on what frequency of radio waves that you use, radio waves can get through the Earth's atmosphere, no problem, okay? So the advantages and disadvantages of using radio waves instead of light waves. Now, the advantage, as I've just talked about, now when you write this down, there's 4 marks, okay? So, you know, write it in nice sentences, that makes sense. The advantage of radio waves is that they can get through the atmosphere easily, okay? Depending on the wavelength, I mean, make a little note on the graph. From those frequencies from there to there, the radio waves can pass through the atmosphere, no problem, okay? Whereas the visible light, only some of it gets through. And if it's a sunny day and you're getting lots of light from the sun as well, that will interfere. The disadvantage is that the radio waves have a lower frequency. Because they have a lower frequency, they can transmit less information. Okay, the bandwidth will be smaller. The bandwidth is kind of the amount of information that you can send every second. Okay, so because they have a smaller frequency, they will have a smaller bandwidth, so it will take longer to transmit the same amount of information. I know I've talked a lot there and I haven't written it down. Hopefully you've been listening and hopefully that makes sense. I'm going to move on. A satellite transmits 2 signals, A and B, to another satellite in orbit around the moon using different electromagnetic waves. The signals are transmitted over the same distance. Signal A has a frequency of blah and takes 1.28 seconds to travel. Signal B has a frequency of blah. Explain how much time is taken for signal B to travel between the 2 satellites. And this is very much a red herring, because one thing that we do know, we remember, don't we, is that all electromagnetic waves, including radio waves, travel at the same speed in a vacuum. So in space, which is a vacuum, all electromagnetic waves travel at the same speed. Write that sentence down, and so the answer is 1.28 seconds because it's the same. Yes? Blimey. That was easy if you know your stuff. Now, a home cinema system can be controlled by either an infrared remote control, so infrared, yeah, infrared remote control, got one of those in your hands quite often, or Bluetooth, okay? Evaluate the strengths and weaknesses of using infrared or Bluetooth to control a home cinema, like just imagine it's a television, whatever. So for controlling it, which is better? Evaluate. Now, evaluate the strengths and weaknesses. And for this question, I believe this is a 6-mark question, this one. It is 6 marks. So, advantages of infrared, advantages of Bluetooth, and then evaluate means come to a judgment based on the evidence. Okay? So, at least 2 advantages of infrared, at least 2 advantages of Bluetooth, write neatly, and you are developing an argument. So you're not writing very brief sentences. It's almost like you're writing an essay. I would allow bullet points. The advantages of infrared are bullet point blah, bullet point blah. However, the advantages of Bluetooth are bullet point blah, bullet point blah. Therefore, I would recommend blah. Yes, that's what we want here for 6 marks. If you've revised, if you've read your revision guide, if you've watched my videos on this, you'll have learned a list of stuff about infrared, and you've learned a list of stuff about Bluetooth, and you'll have the information in your head and you'll be able to answer it. For example, you will know that the infrared is a higher frequency, so it can carry more information in the signal. You will know that infrared, now infrared requires line of sight. So basically, if somebody walks in front of you, then the television won't receive the signal. Okay, so you need line of sight, nothing in the way. You will know that Bluetooth can control several devices at the same time. Yeah. You will know that Bluetooth, you can actually use your mobile phone. Yeah, your mobile phone can transmit and receive Bluetooth. So you'll be able to use your mobile phone to control the cinema system. So remember these advantages, disadvantages, write it down in a sentence, make an argument, and come to a conclusion. What the conclusion is, my conclusion would be that either would be suitable. You can control it with an infrared remote control, or you could control it with a Bluetooth controller. Doesn't matter. Either would be perfectly fine. Neither of them need a router like Wi-Fi. Okay. I don't know. Anyway, now I believe that's the end of the paper. It is. That's the end of the paper. Now, I feel I spent ages on this, but including the bilge at the beginning, I only spent about 20 minutes actually doing the proper paper. I know I didn't write out the big answers, but you should see that it can be done in half an hour if you know your stuff. If you've revised, if you've used those flashcards, if you know your stuff, you can easily get it done and do a good job of it in half an hour. I've got a couple of minutes left. What do? I'm going to go back and check my answers. Yeah, add a bit more information to 1 or 2 of my answers if it needs it. Okay,